Right, then let's begin. So welcome to my talk today, how to really secure remote access to IACS, but keeping it easy. So what's this acronym? It means Industrial Automation Controlling Systems. So these kind of systems that all of you are your business, if I'm right. So the talk is about IT security and how to protect your equipment. Let's start. First slide. So first step, let me introduce myself a little bit. My name is Stefan Fendner. I'm a team leader of the software development at ADSTEC. And who's ADSTEC? Maybe you never heard about it. It's a German company. We're a mid-sized, family-driven business nearby Stuttgart in Germany. We exist since 1980. In the past, we did a lot of industrial automation for local automotive companies. Where nowadays we do more industrial IT equipment. So what's this? What's industrial IT? It means we do industrial PCs, like you see them on the screen there. Industrial firewalls and routers for VPN. We do this business since 2006, so we're more than 15 years now nearly. And we run a big cloud-based VPN remote access service for our customers, or about since 2012, for a long time now. And so I think we have a lot of experience in this field and many happy customers. What's the topics of today's talk? Let's take a look on the overview. First, start with the challenges for automation system manufacturers and operators. So what are the challenges of IT security in factories? How we can do authentication. It's a big important part. And then let's deep dive a little bit into the modern IoT industrial 4.0 buzzwording. Let's distinguish VPN remote access and IoT data acquisition. Both things are important. And at the last, I'll introduce you a little bit what ADSTEC is about to do to solve these challenges. Yeah. So first slide. Industrial automation control systems are under attack. You maybe heard the news lately. We had this pipeline issue in America lately, the last 2 weeks, where some ransomware had hit the pipeline. Actually, it was not the control, but the office, but doesn't matter. It could also be the control system. Pipeline was shut down and there was some fuel shortage. So threats are increasing, and this is true for the past 5 years and will be true for the future. All facilities are always online, so we have this modern data acquisition tools for very smart factories to check all the data, to do predictive maintenance and all this stuff. Not starting with Corona, but for many years we have rare service staff and lots of systems and machines in the fields worldwide, and remote VPN access is required. So it's very productive to run a service crew with remote access to reprogram the PLCs, do some engineering work remotely before really traveling to the site and fix stuff. So we have this issue that we have to be always online with our machines in factories, and on the other side, the attackers are happy if the machines are online. So we have to secure them. So this is a screen I hope you will never see on your automation system. Some ransomware likes to have some money to decrypt the controller, and from Bad Rabbit here in this case. So this is quite a new stuff for automation systems. Normally this was more popular on desktops, but nowadays the attacking crews are also targeting very special equipment because there is lots of money to be earned for them. But the IT security issue for automation systems is not new. So this is some more older news. You see it's from 2013. And was one of the largest attacks on some German steel mill. And there was a large damage. So actually the steel mill was quite done after the attack. There was some broken oven there. The attack was linked to some Russian crew, like was called Cozy Bear named. So also the ransomware stuff is new. The attacks on the systems are not new. We have to be very careful on this stuff. So let me introduce a little bit the wording and the topology, what we discussed today. We have different roles and interests in this topic. First of all, we have the guys which are remotely, the equipment supplier, for example, the programmers, the service staff, and we have machines in the field, inside of the factory over here on the right side, and we have some owner, so the operator from the systems, which has the interest to have a productive system which is online and produces its parts and keeps running. And we have the supplier on the left side, which normally will have some service agreement or a guarantee staff issues where he has to be quickly to fix issues to make the factory running. And then we have the attacker. So the attacker is normally outside. So first of all, we have an external attacker. So if the equipment is here on the World Wide Web, so the attacker can access maybe the whole automation system through the border firewall of the factory, which is normally run by the operator, the owner of the factory, onto your machine. Then the machine will get down, he will call maybe you, and the machine is not running, please get up and do your service, and then you have some problems. So we'll introduce large costs maybe. So it's interest of every manufacturer of the automation system to keep the automation system itself secure, because it means it has higher uptime if it is secure. On the other side, the attacker can also attack the service staff. So for example, if there's a notebook, service notebook or something like that, it's just on the internet. Sometimes it's somewhere else, but in the office, maybe on foreign Wi-Fi networks or whatever. So often the attacker can attack the PC too. And through the PC, maybe without your notice, it can attack the machine. So also an attack vector. So you have to be careful that your PCs are secure. Most of you will do it. Then you have a third possible attacker. So if the machine itself is a little bit corrupt. So let's assume this is not your machine, but some second-hand board machine with a virus on the PC. So the attacker sits here inside and attacks your machine nearby. This is also a possible attack vector. So you have to not only protect the machine from the external access, but also from access from neighborhood machines in the same network, maybe. So let's take a look. What are the interests? To summarize. So for the operator, the owner of the machine, of the factory, he how can he protect his automation system? So he has to protect it by using his border firewall. If the factory, the facility is connected to the internet, normally his network admin will do this. Then how can he issue remote access? So the suppliers normally will have to want remote access to their machines, and the operator, or maybe the administrator of the operator, does not like to give them remote access because it is a security issue for him. On the other hand, the supplier has its service level agreements, and maybe in the contract there is a little small printed clause where it is needed. So what to do? Nevertheless, the interests of both parties are the same. They want no interruption of the production. They want a high uptime of their production systems, and remote access is very helpful to gain this goal. And so what can the admin do of the operator? Normally the network administrators, they're very good professionals. They're familiar with their office firewalls and office VPN stuff from Cisco, Juniper, or whatever, name it. And but they're not very familiar with PLCs. So what does a PLC require for remote access? It's not the same as a PC does. So normally you can work, for example, a little bit with TeamViewer, but you need a desktop. If your PLC doesn't have a desktop, it's a little bit more difficult. So what are the interests of the supplier? So the programmers of the SPLCs, which ship their machines, how can they gain access to all of their machines? So suppose you ship machines worldwide, maybe 1,000 per year, and you want remote access to all of them. So how can you do this? And how do you grant access to your stuff and revoke it? So if someone leaves your company, your service team, how can you tell him forget that password? And how can he access the machine? Because every network administrator of every factory will not like to let him in. But you need some same way to do all this, otherwise it gets too complicated. So all these issues are today's topic, and let's deep inside. Attack vector. In the IT security industry, we talk about attack vectors. That means like a vector, some dart where it can hit the system. So from where can it come from and what does it hit? If we take a look here on this topology, we have now only cut the right part of the previous slide. You see on the right hand, you see the machines. You see this big Fs, which means firewall for every machine. So everyone has one. And you have this production firewall. So the administrator had put here some separation between his office network and the production network, which is good practice. And you see the intranet of the facility, of the factory. So, and what the administrator of this network should know, those who have access to the machine on the right hand. So if he gives remote access to some service stuff from foreign companies, those guys who have access to this machine can also access its intranet. So they could access the ERP system where they shouldn't go. And there's some additional risk. Most machines use very old unmaintained software. So it's common practice to run old Windows desktops there, old PLC software. Even if it's new today, you will maybe do the next service in 5 or 10 years. And there's a good saying, never touch the running system. And so some of the software gets very old and nobody will ever change it. So this means there's a high risk that the machine gets some virus or an attacker finds his home there. So that means for the administrator of this factory, regard all machines with remote access as untrusted, or even regard all machines as untrusted. So it's very important to put this production firewall in between the production and the office network. Or split off. That's the countermeasure one to make a secure system here. It's good practice, and you can use your Cisco firewall 19 Tolerec, no problem. So regarding the second risk with this foreign machine, where the machine is under attack itself or is unworthy your trust, you have to protect against this path. So the attacker should not be able to use a machine to attack the second one. Even the neighborhood, maybe your here some machine of your in German say Mitbewerber. I don't know the German word. So what can you do? You can put in here a firewall packet filter. So this is not an allowed data path. It's the easy go. We call this whitelists. A whitelist here inside of the firewall allows only listed traffic. So for example, if there is really a need to do this data path, maybe it's only for some single special PLC protocol, but not for file shares or something like that. Then you have to do this a strict filter, and then you're on the better side. So on the top you see some ADS-TEC solution. This is one of our firewall routers. They have a key switch, so you can even switch per 24 volts the rule sets. For example, if you do service, you want to reprogram the PLC, you need some more protocols, more data, then you can trigger the switch, and the firewall is a little bit more open. And after you're done, you're back into production, then you switch back again, and the firewall is closed and will only allow what's needed for production. So it's a little bit less risky then. So let's take a look onto the remote access. We are now with the full topology. On the left side, we have the internet. We have a possible attacker on the internet. We have this border firewall, production firewall, and the automation system on the right hand. So the most easiest thing to do, maybe you have done this at home too, is to use a TCP port forward. What does it mean? You put here into the border firewall some rule set, and it allows some special path to go through. For example, TCP port, whatever, let's say 80. So a web server on the PLC is now on the internet, unencrypted. Everyone with the right password of the PLC here, so the equipment has a web server with password, can now take a look what the PLC is doing. The attacker can too, but you say he doesn't have a password. It's okay. So that's easy to do, only a little bit of configuration here. So what you cannot do is to do a filter here. Normally you would say, okay, I know my source. I have a trusted IP address. The source is allowed, other sources are not. That will not work because we have dynamic addresses from the service stuff normally. So this will not work. Everyone can access. So what does it mean? Maybe it's okay for the first 2 years, and then there's a flaw in the software of the automation system here. So we have a leak here in the software, and most likely nobody will notice because nobody takes a look on which version of that web server is running there. But some guys do, the attackers, they will find the web server here, they will see the version and will see, oh, it's vulnerable. I can bypass the password. And then you have your PLC on the internet for everyone to control it. That's the worst case. So you see, a port forward is easy to configure, but it's a very bad idea to do. What can we do to make it better? A better concept is remote access without forwards. So let's take a look onto this topology. On the left hand, we have the service staff. He will build up a VPN connection to some trusted host on the internet, so a server system. On the right hand, we have this VPN router on a machine here, and we'll do the same. So we have this path and we have this path. So everybody joins in here at this server in the middle and meets there. The server has the task to switch together those paths. So there are many benefits in this topology, in this concept. First of all, the connections start by singles machines here from the inside of the network to the outside is more easy to control. Normally, most border firewall will allow outgoing requests very openly. Otherwise, you can allow special IPs, this single IP address of this meeting point or several IPs, to go outside. So the border firewall is easily to control, allow that machine to go online to that IP address. Most admins of this production firewalls and border firewalls will do this. It's their daily business to allow this stuff. The service stuff also connects to the single IP, so it's no problem for it, even from today, from at home or from the office. It's no issue there. And now the attackers are are unable to attack. Neither the machine can be attacked because it's no open port here. You cannot come from here, so it will not be possible. So it's blocked, no way inside here. And you cannot access the notebook too by this way from the software of here. There's no data path inside of the notebook. Only this one. Only the trusted meeting point is attackable, and he had to be protected. So that's the important part here in this concept. You only have to protect one system compared to many systems here on the right side, many production systems and many notebooks. So it's an easy task. For ADS-TEC, as we run this as a service called Big Links, this meeting point, it's a daily task. So we have professional IT security specialists and administrators which do this task as their daily business. So it's secure. So just a little bit better than port forwards. Actually, it's the best concept, I think. Let's switch to the next one. After many years in this business, we had always this little paranoid guys at the factory. I don't like to have this machine online on the internet. I like to switch it on when there is a problem. Otherwise, I pull the plug. So, and one method to convince them, because we want to really have to this data all the time for our condition monitoring here, is a 4I principle. So what can we do? We take two humans, service staff on the left side and operator on the right side at the machine. And with the place a switch, the key switch with a real physical key or a physical connection to the PLC with some stuff on the HMI. And he has to press a button or trigger the key switch to allow the machine to go online. On the left side, there has to be a human which has to accept the service request here on the host. So only when there are two humans, the data path is opened and they can take their phone and call them each other like it's on TeamViewer. On TeamViewer is the same concept with the pin. No? So this way, securities are minimized because the VPN connection cannot be started automatically in this way in the setup. It takes a human to trigger the switch. And that's good because even if the VPN connection would be online all the time, it's an additional risk. So if you don't have humans on site, some sites don't have humans, they are all automated, no humans there, you can connect the PLC there and the PLC can call home if you need it. Also a possibility. So even for the more and more paranoids, they were not happy with the solution. They say, no, I don't like to have an internet connection. I cannot. Our policy is not to connect the machine to the internet. Then what can we do? We can place some LTE router here at the machine. In this case, the firewall on the right side has some LTE modem inside. It can go online through mobile networks. But normally, as the operator will not allow this, it is offline. No? So now in the case, the switch is triggered. The system will go online and it will cut off all connection to the local production network. So the machine is isolated from the production network and will go online to the internet, which means the whole production system is always not connected as required to the internet, but only the machine, the single machine with a single problem, will connect to the meeting point where he can meet his service staff, which can do his analysis, reprogram the PLCs or whatever. And if it's done, you can call this person here, tell him to trigger the plug again, and then the LTE modem will go offline and you're back. So what does it mean? The machine itself is completely isolated at the time of remote service. There is no connection, no possible connection at all for the service technician to do access any other network component in the automation system or in the office backend of this automation system. No possible, because there's no cable. So this is equal to sending back the machine to the manufacturer for service. Yeah? There's no way to harm anything. So this is great for the paranoid operators. It's normally a concept which will be accepted in all cases. And it's also great for your service staff, because now you can access there and don't have to jump into the plane or the car to go to on-site. So next slide, authentication. What can we do about authentication? What are the challenges here? So main problem is how do we authenticate these service guys here, these programmers and technicians? And how do we authenticate also the machines? Because we want to access the right machine, not the wrong one. So the first thing we all know are passwords. You can protect equipment with some password, and it's done. This is okay maybe for a single technician and a single machine, but passwords can get lost. You all know this little yellow papers with the password on the screen, and tuck, they are gone. So passwords are not a very good authentication method. And now suppose you have 1,000 machines per year which ship worldwide, and they all get the same password for access. And sometimes you will have to change it. Will not work. So what else can we do? X509 certificates. So just a common certificate for authentication can be used. Every machine will have a certificate, and you run some public key infrastructure in the backend and distribute it. That's good. It's a lots of work. It's complicated, but it will work. But there's some small problem. Certificates can be copied. So maybe someone can steal the certificate from this service PC. The attacker can ship. This is the certificate, cert, steal it without him to notice. Now he can access the machine. Or put some ransomware there. So certificates can be copied. That's a problem, no? And how can we revoke access of a service technician? So if the service technician leaves the company, we have to revoke his access. So how does this firewall here know that this technician is no longer authenticated? Even if he has an old certificate, which is still valid, but revoked, we have to tell the machine here. 1,000 machines per year online with difficult networks still does not work. So it's a big challenge. What can we do? So ADS-TEC had come up with smart cards. Smart cards are quite old technology. You all have them in your pocket for your banking account. And they're very strong authentication method. They're also the oldest two-factor authentication that we know. So we have this PIN. Every card has a PIN, and the PIN protection will authenticate the human behind the PC, not the PC itself. So it's much more better than a simple certificate on the PC. Now every technician, suppose, has a smart card PIN protection. The authentication certificate is stored on this card. So we have a little secret here inside, and it cannot be extracted. It will always remain here. It's the private key of the certificate. You cannot copy it. It's not possible. If you accomplish this task to copy it, you can do many more worse things. For example, steal every money on every banking account. So this pin is the second factor. He knows the pin in his brain. So this is the second factor. The machine's router can have one of these things too. There's no second factor in this case, but still the benefit that it cannot be copied. And yeah, the cards now can be blocked easily. So we have the server in the middle here, and therefore we have single point where all certificates can be authenticated against the central database. So we have this database, and we know who is valid and who has left the company, and can revoke the access. So it's easy to maintain. So of course, you can build such a system of your own. So it's no very rocket science here, but it's lots of work, and you have to keep the server running and keep the server secure. Or you book some ADS-TEC service. In this case, our professionals will do this for you. Now let's take a look into the topic data acquisition. What's the difference to VPN remote access from an IT security point of view? So yeah, we have this gray channel here. It's new, the gray line here. That's a little bit red. This is our IoT data channel. So the machines transmit data to our central server, which is on the internet, to be able to take up all the data. And from a security point of view, such a channel should be unidirectional. So data should go outside of the machine here, but not necessarily in the opposite direction. If it goes in the opposite direction, it poses some possible risk, some attack vector for an attacker who could use this protocol to do some malicious stuff. So if we distinguish this, so the VPN remote channel is bidirectional. So here the data is running in both sides. So this is the main difference. Now what can we do? We can run this VPN remote access with this key switch, as we already discussed, as you know it now. The human will switch on the access control or off, but this will not influence this second data channel. So if we can distinguish here these channels on the firewall and run the switch only for the VPN and have a unidirectional here, that would be a good concept. So some risk remains. If we build up such a system with popular IoT protocols like MQTT or OPC UA, they are complex and they are not really pure unidirectional. So both of these protocols allow configurations with the other path direction. So the ADS-TEC solution is that we did some custom unidirectional JSON protocol, which is unidirectional. So with this concept, we had lots of discussions with factory admins, and at the end they all accepted this, because there is no risk for an attacker, even if he would gain control over our central trusted host to attack the machine. So let's take a look what ADS-TEC offers you for you if you are interested. This is our system, big links. It combines all the stuff together. It's a big public key infrastructure behind. Every end device will get smart cards produced by us. And at the right hand, you see the routers, LTE routers, robust routers, cheap routers, if you have a cheap machine. And on the left hand, you see some IoT dashboards. There's also some IoT dashboard integration in big links to really take up the data for analytics and databases. So it's plug and play, because you can really plug it in and it will work and it will be secure. And you can focus on your parts by to build great machines and great PLCs and great PLC programs and keep the security to the professionals. So this is the hardware, just to look on it. On the left hand, there's some new one. It's more lightweight, more cheaper, and also has some RS485 for Modbus RTU. All of this stuff comes with LTE switches inside, smart card readers, and all have these key switches. There's no vendor login, so you also can use this for your own VPN servers. You can also build these topologies by your own, by using IPsec or OpenVPN. So you're not really bound to us if you buy such a device. It's a quite open industrial router. So that's all from my side, and I will open the channel a little bit to the moderator. If there are any questions, please ask them, put your hands up, and the moderator will allow you to speak. Thank you.
Thank you very much. So as Mr. Stefan said, if someone has any questions, and please, maybe you don't have to use your hands. You can just unmute yourself and ask. But I think it was so many information that many of us will have to take some time to process it. Oh, as you can see, someone in chat write to you in German.
Oh, let's take a look. Just it was good and a good topic. Thanks. That's all what he wrote. Okay.
So actually, I think I might have a question. Maybe I can start.
Sure.
Okay, so you said that you know some operators who are afraid and they want to have as many security measures as possible. Yes. But is this how many of them want to have as safety system as possible? It's about 90%, or maybe it's not as common thinking.
Yeah, it is. It depends on the size of the factory or the operator. If you take a big companies like Mercedes-Benz or WV or something like that, then they have a big IT department, and these big IT departments have very straight policies. And they also have guys who only do this as their main job, and we have to convince them that your solution is secure. And do some certification on the audits and all this stuff to get inside of the plant. If there is just a small company, so maybe you have only a single factory, family owned, and 100 employees, and no IT admin at all by a professional IT admin, then you will have no problems at all. They will allow you anything, because nobody is aware of it. And then you have the third type of customers where they already have experienced IT security issues, and they are very aware and independent of the size. Yeah.
Okay, thank you. Okay, so if some of you have questions in the future, then you can contact us. We will send this question to Mr. Stefan. I hope you can then answer us if someone will have a question.
Yes, for sure. So feel free to answer any questions. Yeah. Okay. Great, Dan. Thank you for your interest, and maybe we'll meet sometime in the real world again.
Yes. Yeah. Thank you very much for your presentation.